In the first example, to work out the half-life, we start off with 100, and half of 100 takes us to 50. We draw our line across, and where it meets the line we then draw it down vertically, and you can see that approximately it works out as 5 days. We take our next one, it's the radioactivity starts at 80, so the half-life will be at 40. We draw again our line horizontally across and vertically down, and we can see that it meets at 4. So the half-life for this one will be 4 days. For these next ones, they're slightly trickier. We need to work out the half-life of a source of carbon-14, which is 5,760 years. After how many years will the number of radioactive particles left be 12.5% of the original amount? If we think of the original amount as being 100%, we know that every half-life it's going to be halving. So after one half-life, it will take us down to 50%. Our second half-life will bring us down to 25%, and our third half-life will bring us down to 12.5%. So we know that when we get down to 12.5% of the original amount, 3 half-lives would have passed. So if one half-life takes 5,760 years, the next one taking 5,760 years, and the third one taking 5,760 years, the total of these 3 numbers will be the time it takes, which is 23,040 years. In the next question, it tells us the half-life of radon is 3.8 days. It gives us the original activity of the source, and it asks us what we'd expect it to be after 15.2 days. Well, we know that one half-life is 3.8 days, so therefore, to get to 2 half-lives, it would take 7.6 days, 2 lots of 3.8. Our third half-life would take us up to 11.4, and finally our fourth half-life would take us to 15.2 days. We therefore know that after 15.2 days, we'd have gone through 4 half-lives. So if we started off with 2,400, after one half-life, which would be the 3.8 days, we get to 1,200. After our second half-life, we get to 600. Our third half-life would take us to 300, and our fourth half-life would take us to 150. So the answer would be 150 becquerels. The last question is a little bit trickier. It's telling us that uranium decays, producing alpha particles to leave something called thorium. It gives us the half-life of uranium, and it asks us how much thorium would there be. What we need to do is we need to consider what would be going on. So originally we'd start off with 480 grams of uranium, and we wouldn't have any thorium. After one half-life, the uranium would decay to 240. The remaining 240 would therefore turn into thorium. After our second half-life, 240 of uranium would turn into 120 of uranium, with the net remaining 120 turning into thorium. So after 2 half-lives, we would have not only 120, but the original 240, we'd have 360 of thorium. After the third half-life, it would go down to 60, and again 60 would go over here, giving us a total of the original 360, plus what we had, which was 420. So after our fourth half-life, 30 again will go over here. We've already got 420 of thorium, plus the remaining 30 that we've got here, bring us to 450 grams. So our answer would be 450 grams.